Fractions are an essential part of mathematics, but they give a lot of students trouble because they seem to have complicated rules for how they interact. I'd like to clarify that. The rules are not so bad, you just have to remember the important tricks. So unlike with normal numbers, where I think adding is easier than multiplying, adding fractions can be a bit of a pain. The key is to get what's called a common denominator. So if I have a divided by b plus c divided by d, I need to compute b times d. And this is what's called a common denominator. If you can remember to do this for fractions, you'll be in good shape. Multiplying fractions by comparison is much simpler. I do what I would love to do for addition. I just multiply the numerators, multiply the denominators, and I get my multiplication of the fraction. Right? So b times d is just the product of the denominators, and a times c is the product of the numerators. So to me, multiplying fractions is more natural than adding them. In adding them, I have to find a common denominator. You do not have to do that for multiplication. And then there is one other thing we might need to look at, which would be what's called improper fractions. You can also think of this as dividing fractions. And the rule is somewhat more complicated than multiplying them. To get the new numerator, I take the old numerator and on the bottom, the denominator, to get a times d. And to get the new denominator, I take the denominator on top and the numerator on bottom. Okay? You can think of this also as like a reciprocal rule for fractions. It goes by many names. It is somewhat important for the CLEP, but less important than adding and multiplying fractions. Okay, so to learn how to use these things more efficiently, we should just do some practice. So let's look at a couple examples with both variables and numbers that will illustrate how these rules work. So our first example is with multiplying fractions. So I have a to the fifth times b squared divided by a cubed times b. And I'd like to simplify this. Well, what I need to do is just remember how to get products of fractions. Right? So I can write this as a to the fifth divided by a cubed times b squared divided by b. And then, okay, we will review this, how to divide powers in just a few modules. But in this case, I think it's fairly straightforward. I have a 5 minus 3 times b 2 minus 1. And this simplifies very cleanly to a squared times b. Okay, so my big mess at the beginning, this a to the fifth times b squared divided by a cubed times b, simplified very nicely to just a squared times b. And all I had to do was remember the product rule for fractions. So let's look at something a little bit more complicated. We're going to go on to addition, which, again, I think adding fractions is more challenging than multiplying them because I have to find a common denominator. So let's look at an example where we actually have three fractions I want to add together. I want to add 1/3, 7/5, and 2/7. All three of them have different denominators. So I'm going to have to do something very kind of tricky. I'm going to have to find a common denominator that works for all three. You can do this in one shot, but I'm going to look at it as first add 1/3 and 7/5, and then add 2/7 to that. So we'll start by saying that this is equal to, well, how do I add 1/3 and 7/5? I find a common denominator for them. So that will be 3 times 5. So I have 5 divided by 3 times 5 plus 3 times 7 divided by 3 times 5. And I'm not going to touch 2/7 yet. I'll first add 1/3 and 7/5 and then touch 2/7 at the end. So I get 5 divided by 15 plus, 3 times 7 is 21. So 21 divided by 15. And now, okay, I can add these. They have the same denominator. So I have 26 divided by 15 plus 2/7. Okay, so now I have two fractions I have to add. I play the same game. Find a common denominator. So 26 times 7 divided by 7 times 15 plus 2 times 15 divided by 7 times 15 they have the same denominator now, so I can add them. So let's see, I have 26 times 7 is 182. 7 times 15 is 105. 2 times 15 is a little bit easier to compute. This is just 30. And then 105. And at last, I can combine them to, okay, this is 212 divided by 105. So wonderful, right? Complicated looking problem. All we had to do was find common denominators twice. Okay, again, this is not the only way to do this. One could find a common denominator for all three denominators right at the start and add them this way. But I think somehow it's nicer to first add the first two, and then once you have that, add it to the third one. It's sort of fewer opportunities for error. So finally, let's look at an example where I have to add fractions, but the fractions are actually variables. Okay, it somehow looks much harder because, x could be anything, right, in this case. But the same rules apply. I just need to find common denominators, and then I can add these fractions. So the question is, what is the common denominator here? Well, it helps in this case if you can factor x squared minus 1 correctly to x minus 1 times x plus 1. And then this guy stays the same. And now it seems like, oh, well, my common denominator should be x minus 1 times x plus 1. So I get 3x minus 1 divided by x minus 1 times x plus 1 plus x plus 1 over x minus 1 x plus 1. Okay, now I have a common denominator, so I can add the fractions and get 3x minus 1 plus x plus 1 divided by x minus 1 times x plus 1. And I'll just clean up the numerator a little bit. I have now 4x, and then the minus 1 and the 1 cancel. So if you like, you can leave it like this, or you could multiply x minus 1 times x plus 1 out in the denominator and get x squared minus 1. But I say that we are done. We have successfully combined our fractions, and even though they had variables, all I had to do was find a common denominator, and that's this step here. So this is a very important thing to know for the CLEP. There will be questions about finding common denominators and adding fractions on their own, and they will also be used in questions that build on this. So it's really an important thing to nail down before trying to take this exam to get college credit. It's really essential to our work.